Welcome students in Excellence Classes Way of Learning. Today we are going to discuss real numbers part 5. In this class we will discuss exercise 1.3. Okay students, here question number 1, prove that under root 5 is irrational. Students, here we use contradiction method to prove these type of questions. So here first question is prove that under root 5 is irrational. Okay. So here let us assume to the contrary. Let us assume to the contrary that under root 5 is rational. Okay. Students, all of you know that rational numbers can be written in the form of P upon Q. So here under root 5 is equals to A by B, where A and B are co-prime and B does not equals to 0. Okay. Now squaring on both sides. So here we get under root 5 square is equals to A upon B whole square. Here 5 is equals to A square upon B square. So it is equals to 5B square is equals to A square. Let it equation first. Clearly we see the product of 5 and B square is equals to A square. So this shows that A square is divisible by 5. Okay students. Here A square is divisible by 5. So it follows that A is divisible by 5. Okay students. Let it equation second. So here A is equals to 5m for some integer m. So here we get A is equals to 5m. Okay students. So now substituting A is equals to 5m in equation first. Okay. So here we get 5b square is equals to, here A is equals to 5m. So here 5m whole square is equals to 25m square. Okay. Here B square is equals to 25m square upon 5 is equals to B square is equals to 5m square. Okay students, clear? So here we clearly see that B square is divisible by 5. Okay. And hence B is divisible by 5. Divisible by 5. Let it equation third. Okay students. So here from equation second and third. From equation second and third we can conclude that 5 is a common factor of both A and B. Okay. From equation second and third, where B is divisible by 5 in equation third and A is divisible by 5 in equation second. So here we can conclude that 5 is a common factor of both A and B. Okay. But this contradicts our supposition that A and B are co-primes? Listen carefully, students. We can conclude that 5 is a common factor of both A and B, but this contradicts our supposition that A and B are co-prime. So our assumption was wrong. Hence, under root 5 is irrational. Okay, students? Now, next question. Question number 2. Prove that 3 plus 2 under root 5 is irrational. So here 3 plus 2 under root 5. Okay. Let us assume to the contrary that 3 plus 2 under root 5 is a rational number. Okay, students? So here let 3 plus 2 under root 5 is equals to A upon B, where A and B are co-primes and B does not equals to 0. Okay. So here 2 root 5 is equals to A upon B minus 3. Here under root 5 is equals to A upon 2B minus 3 by 2. Okay. Clear? Okay. Since A and B are integers, therefore A upon 2B minus 3 by 2 is a rational number. So under root 5 is a rational number. Here A upon 2B minus 3 by 2 is a rational number. So here under root 5 is a rational number because under root 5 is equals to A upon 2B minus 3 by 2. So here under root 5 is a rational number. But we know that under root 5 is an irrational number. Okay. Here we know that under root 5 is an irrational number. This shows that our assumption is incorrect. Okay, students? So 3 plus 2 under root 5 is an irrational number. Okay. Here our assumption is incorrect. So 3 plus 2 under root 5 is an irrational number. Okay, students? Let's see again. We have to prove that 3 plus 2 under root 5 is irrational. Let us assume to the contrary that 3 plus 2 under root 5 is rational number. Here let 3 plus 2 under root 5 is equals to A upon B. Here we get under root 5 is equals to A upon 2B minus 3 by 2. Here A upon 2B minus 3 by 2 is a rational number. So under root 5 is a rational number. But we know that under root 5 is an irrational number. So this shows that our assumption is incorrect. So 3 plus 2 under root 5 is an irrational number. Okay, students? Clear? Now next question. Question number 3. Prove that the following are irrationals. Here first is 1 upon under root 2. Okay. So here let us assume to the contrary that 1 upon under root 2 is rational. Okay, students? So here let 1 upon under root 2 is equals to A upon B, where A and B are co-prime. Okay, and b does not equals to 0. Okay. Here we have 1 upon under root 2 is equals to a upon b. Here on rationalizing 1 upon under root 2, here we have 1 upon under root 2 into under root 2 upon under root 2 is equals to a upon b is equals to under root 2 upon 2 is equals to a upon b. Here under root 2 is equals to 2a upon b. Okay students, since a and b are integers, therefore 2a upon b is rational. Okay, so under root 2 is rational because under root 2 is equals to 2a upon b. So here under root 2 is rational, but we know that under root 2 is a rational number. So here, but this contradicts the fact that under root 2 is irrational. Okay, so we conclude that 1 upon under root 2 is irrational number. Okay students, clear? Next, here second, 7 under root 5. Okay, here again let us assume to the contrary that 7 under root 5 is rational. Okay, here 7 under root 5 is rational. That is 7 under root 5 is equals to a upon b, where a and b are co-prime and b does not equals to 0. Okay, so here under root 5 is equals to a upon 7b. Okay, since a and b are integers, therefore a upon 7b is rational. Okay, therefore a upon 7b is rational. So here under root 5 is a rational number. Okay students, since a and b are integers, therefore a upon 7b is rational. So under root 5 is a rational number. But this contradicts the fact that under root 5 is an irrational number. Okay, so here we conclude that 7 under root 5 is an irrational number. Okay students, clear? Here next question, third, 6 plus under root 2. Okay, again let us assume to the contrary that 6 plus under root 2 is rational. Okay, that is 6 plus under root 2 is equals to A upon B, where A and B are coprime and B does not equals to 0. Okay. So here under root 2 is equals to A upon B minus 6. Okay. Here, since A and B are integers, so we get A upon B minus 6 is rational, and hence under root 2 should be rational. Okay, but this contradicts the fact that under root 2 is irrational. So here this contradicts the fact that under root 2 is irrational. Therefore, our assumption is false, and hence we conclude that 6 plus under root 2 is irrational. Okay students, let us revise. Here we have to prove 6 plus under root 2 is irrational. So let us assume to the contrary that 6 plus under root 2 is rational, that is 6 plus under root 2 is equals to A upon B. Here under root 2 is equals to A upon B minus 6. Since A and B are integer, we get A upon B minus 6 is rational. So under root 2 is a rational number. But this contradicts the fact under root 2 is irrational. So we conclude that 6 plus under root 2 is irrational number. Okay. Exercise complete. Okay students. In next class, we will discuss exercise 1.4.